Hi, welcome to the Dynamics tutorials. So in this case we're going to look at a problem using power and efficiency with a work and energy approach. So we have a crate that's suspended by a massless frictionless pulley and then the cable attaches to the ceiling on this end and then attaches to a motor on this end. So the motor has an efficiency of 0.75 or 75% efficiency, and the motor has a supply of 1 kilowatt of electrical power. So we want to find out what the acceleration of the crate is if it's already moving up 1 meter per second. So the first thing we can do is relate the rates together. So we have this pulley that might be translating up and down. So we want to map that distance with this S. So we can say that the length of the cable in this pulley system must be equal to 2 lengths of S plus some constant. I just omitted the constant here. And then we'll take our derivative of length with respect to time, and we'll get that dl dt is equal to 2 s dot. Remember that s dot is just ds dt. So then we plug in our s dot. It's moving up at 1 meter per second. Technically should be negative there. Let me jot that down. And that'll give us that the length is changing at a rate of negative 2 meters per second. So in other words, that means your rope is going into the pulley then at 2 meters per second. So then let's think about the efficiency. So the efficiency is equal to the output divided by the input. So if we multiply through by input, we'll get that the power output is equal to the efficiency 0.75 times the 1 kilowatt now multiplied by 1,000 to convert to watts, and we get that we have 750 watts of mechanical power that the motor is now providing. So let's look at our free body diagram. So we've got the weight of our crate, 100 kilograms times 9.81, and then we have 2 of these tensions that we had to cut, so we have 2T going up. Then we can do our sum of forces in the y direction is equal to the mass times acceleration in the y direction. So we've got those 2T going up, we've got the weight coming down, and then that's equal to the mass of the crate times acceleration in the y. This equation still has 2 unknowns, so we can't solve it yet. So let's look back at our power equation. So we know that the power is equal to the force dot V. In this case, the force and the velocity are both going in the same direction. So this is going to be that our power is equal to our force times our velocity. We can use this to solve for T, which is 375. Notice the negative sign goes away because the tension is pulling up on the rope and it's moving up. So we get the 375, we plug that in here for 2T. That's still smaller when we do 2 times 375 than the weight of the object. So this left-hand side still winds up being negative. So when we solve for the acceleration in the y, we still get a negative number. So that means even though the motor's being supplied power, the power being supplied to the motor is not enough to keep it accelerating in the upward direction, but it is enough to keep it from going down at the full 9.81 meters per second squared. Thanks for watching.